Good morning, class. Today we're going to be starting off our first math unit. I hope everyone had a great weekend and is back and ready to learn. Let's start off today with our standard. Use words, models, standard form, and expanded form to represent and show equivalent forms of whole numbers up to 10,000. And now, the three objectives to fall under our standard. 1. The student will be able to match numbers in digit form to numbers in word form. 2. The student will be able to construct numbers using different models. And 3. The student will be able to translate numbers in standard form to expanded form and vice versa. Now that we went over the basics, let's do a quick warm-up. This warm-up should be relatively familiar from math last year, but if you are struggling at all, please do not be afraid to ask any questions. What is 953 in digit form? Okay, so if we remember from last year, writing numbers in both digit and word form is very important, but we only went up to 1,000, so this number should be a piece of cake. We take the 900, which would be the first number in the number 9. Then we take the 50, which is the second number in the number 5. And then we take the 3, which is the last number in the number 3, to get the number in digit form to be 953. Now, we are going to learn how to do this same process but with numbers up to 10,000. So, we are going to watch a quick video on how to do so. Numbers in word and digit form. For the first part of this lesson, we will be talking about how to write numbers in both word and digit form all the way up to 10,000. Everyone should know how to do this with numbers up to 1,000, but I will make sure to do a little bit of review as well. First, we will go over single digits in the ones place. 1 equals 1, O-N-E. 2 equals 2, T-W-O. 3 equals 3, T-H-R-E-E. 4 equals 4, F-O-U-R. 5 equals 5, F-I-V-E. 6 equals 6, S-I-X. 7 equals 7, S-E-V-E-N. 8 equals 8, E-I-G-H-T. 9 equals 9, N-I-N-E. And 0 equals 0, Z-E-R-O. Next, we will go over the double-digit numbers in the tens place. Remember, here we will go up by tens to represent each base number with no loose ones. 10, 20, 30, 40, 50, 60, 70, 80, and 90. Once you have all the bases for the tens place, you can easily make a double-digit number by simply adding one of the single digits numbers, the ones place, into the ones place of the double-digit number. Next, we will go over the triple-digit numbers in the hundreds place. Remember, here we will go up by 100s to represent each base number with no loose ones or tens. So we have 100, 200, 300, 400, 500, 600, 700, 800, and 900. Once you have all the bases for the hundreds place, you can easily make each triple-digit number by simply adding one of the double-digit numbers into the tens place and then one of the single-digit numbers into the ones place. Now here is when we move up past 1,000 and go over every number that has 4 digits in the thousands place. However, the pattern is similar for every base we go up. We just always add another digit. So we'll go up by 1,000s to represent each base number with no loose hundreds, tens, or ones. So we have 1,000, 2,000, 3,000, 4,000, 5,000, 6,000, 7,000, 8,000, and 9,000. Once you have all the bases for the thousands place, you can easily make each 4-digit number by simply adding one of the triple-digit numbers in the hundreds place, one of the double-digit numbers in the tens place, and one of the single-digit numbers in the ones place. For example, if you have the number 8635, you would label each of the digits, and so from the 8, you'd get 8,000 because it's in the thousands place. And from the 6, you would get 600 because it's in the hundreds place. From 3, you would get 30 because it's in the tens place. And from 5, you would get 5 because it's in the ones place, giving you a total of 8,635. Then, going from word to digit form, if you have the number 5,193, you would take the 5,000 and put it in the first thousands place, the 100 and put it in the hundreds place, the 90, put it in the tens place, and the 3 and put it in the ones place to give you a total of 5,193. Now that we have watched the video and got a quick understanding of how to write out numbers, let's practice. First, let's take a number in digit form and convert it to word form. What is 5824 in words? So, as we learned from the video, we have to break up each part of the number and put it into words. To start, we take the first digit, in this case the 5, which represents 5,000s because it's in the thousands place, and in words that is 5,000. Then we take the next digit, in this case 8, which represents 800 because it is in the hundreds place, and in words that is 800. Then we take the next digit, in this case 2, which represents 20 because it is in the tens place, and in words that is 20. Lastly, we take the last digit, in this case 4, which represents a 4 because it is in the ones place, and in words that is 4. Then we get our final answer of 5,824. Next, let's do the opposite and take a number in words and convert it into digits. What is 6,439 in digit form? So, as we have learned from the video, we have to take the number from each base of the entire number and put it into digit form. To start, we take the first number word, 6,000, and use the 6 that represents the thousands place and put it as the first digit. Then, we take the next number word, 400, and use that 4 that represents the hundreds place and put it as the second digit. Then, we take the next number word, 30, and use the 3 that represents the tens place and put it as the third digit. Lastly, we take the last number word, 9, and use the 9 that represents the ones place and put it as the last digit. And we get our final written out digit answer of 6439. Now, after doing 2 practice problems, let's play a matching game. Match the written number word to the digit number word. Next, let's talk about numbers in model form. Although numbers can be represented by any type of model or object, for this case we are going to be using base 10 blocks. In the picture below, you can see 4 different types of blocks we will be using to represent numbers up to 10,000. The first big block is the thousands block. So each of these blocks equals 1,000, and you can add as many as you want to get into a higher thousands place. The next block is a hundreds block. So each of these blocks equals 100, and you can add as many as you want to get a higher hundreds place. The next block is a tens block, and each of these equals 10, and you can add as many as you want to get a higher tens place. And lastly, the last block is a ones block, and you can use as many of these as you want to get into a higher ones place. Now that we know what each block represents, let's practice. write out in digit form what this picture of base 10 blocks represents. So, as we can see, in this particular set of blocks, there are 2 thousands blocks, which would represent 2 thousands, which the first digit in the number would then be 2. Then we notice that there are 2 hundreds blocks, which would represent 200, which is the second base digit number 2. Then we can see that there are 3 tens blocks, which would represent 30, which is the third digit in the number 3. And then, lastly, we can see that there is one ones block, which would represent 1, which is the last digit in the number 1. So, if we put that all together and see that the total number of blocks is 2,231. Now, after doing this practice problem, let's play a matching game. Match the number to the base 10 block picture. Lastly, let's talk about converting numbers from expanded form to standard form and vice versa. Let's watch a quick video on how to do so. Lastly, in this lesson, we will be talking about how to convert numbers from standard form to expanded form and vice versa. Let's start with converting a number from standard form to expanded form. Say we have the number 4,962. Let's think about what place each of these digits are in. The 2 is in the ones place, the 6 is in the tens place, the 9 is in the hundreds place, and the 4 is in the thousands place. And now let's talk about what each number literally represents. The 2 equals 2 ones, which is just 2. The 6 is in the tens place, so the 6 equals 6 tens, which is just 60. The 9 equals 9 hundreds, which is 900. And the 4 equals 4 thousands, which is 4,000. So putting this number in expanded form means writing out the sum of all these numbers. So 4,962 equals 4,000 plus 900 plus 60 plus 2. And that's your final answer. Now we're going to do the opposite of putting a number in expanded form into standard form. This way is a bit easier than the other one, and we explained all the super details of breaking up a number earlier. So let's say we have the number 7,000 plus 300 plus 20 plus 8. To condense this number, all you have to do is take the first number of each expanded number, 7 from 7,000, 3 from 300, 2 from 20, and 8 from 8. And then you put it all together to make one number, 7,328. Now that we have watched the video and got a quick understanding of how to write numbers in standard and expanded form, let's practice. First, let's take an expanded number and put it back into standard form. What is 9,000 plus 300 plus 20 plus 8 in standard form? So, as we learned from the video, we have to take the first digit in each expanded form of each expanded number and put it together to form the standard form of the number. So, we take the 9 from 9,000 as the thousands digit, and the 3 from 300 as the hundreds place, the 2 from 20 as the tens place, and the 8 from 8 as the one place to get a standard form of the number to be 9,328. Now, let's try putting a number from standard form into expanded form. What is 1,693 in expanded form? So, as we learned from the video, we have to show what each number literally represents in the place that it is in. So, we have the 1 in the thousands place that it will equal 1,000. we have the 6 in the hundreds place that would equal 600. We have the 9 in the tens place that would equal 90. And we have the 3 in the ones place that would equal 3. So we put all the 4 expanded numbers together and get 1000 plus 600 plus 90 plus 3. Now, after doing 2 practice problems, let's play a matching game. Match the expanded form of a number to the standard form of a number. Now, let's put everything together. We're going to take a quick formative quiz on everything we have learned in this lesson. First question, which of these is equal to 5,601? As we can see, this is a standard form of a number. So we can either break it up into words or we can break it up into an expanded form based on which answer would be correct. So we have the 5 in the thousands place, which is 5,000, and we can see both A and B have 5,000. Then we have 6, which is in the hundreds place, so it'd be 600, which A, correct, has 600. However, in B, we can see 6 represents 60, which is the tens place. So we know B is wrong and A would be correct. Next, we have what number is equivalent to the blocks. The picture is kind of small, but it's in the top right corner. So we can see first, we have the 2000s blocks. So we can either put it into word form or standard form. In word form, it does say 2000, which is correct, and in the thousands place of standard form, there is a 2, so both would be correct so far. Then we see that there are 200s blocks, so we go back over and see, oh, the word form says 300, so we know that is not right anymore. However, B is correct, and there is a 2 in the hundreds place, which is 200. But let's just make sure the rest of it is correct. So there are 3 tens blocks, and we can see that there's a 3 in the tens place in B as well, 1 block, and there is a 1 in the ones place, so B would be correct of 2,231. Next, we have what number is equivalent to 7,000 plus 200 plus 10 plus 4. This number is an expanded form, and we have to either convert it into the correct form of standard form or into words. So we have the first number being 7,000, so we check in A. The first thousands digit is 7, which would be correct. And in words, it does say 7,000, which is also correct. So both are correct so far. Then we have the second part of the expanded form as 200. So we look in A at the hundreds place, and it is a 1, which is incorrect because in the question it was asking for 200. So in B, we see that in word form, it is also 200, which is also correct. Then we see in the expanded form, just to make sure B is still correct, that there is 10 in the tens place, and that is 14, because 14 is 10 plus the 4, which is a double digit in the expanded form, so B would be correct. Next, we have what number is equivalent to the blocks. Again, the picture is kind of small, but it's in the top right corner. So we start with the thousands blocks. There's 1,000 block in this picture. So we look at A in the written form, and we see that it says 1,000, which means A is correct so far. And in B, the expanded form, 1,000 is at the thousands place, which is also correct. Then we look at the hundreds blocks. There are 3 hundreds blocks in this picture. So we look at the written form, and it says 300. Which A is correct so far again. However, in B, in the hundreds place of the expanded form, it says 600, so B is now incorrect. Just to make sure A is still correct, let's count the tens blocks. In this picture, there are 6 tens blocks. So we look at the expanded form and make sure it says 60, and it does, and that's correct. Then we count the individual ones blocks and see there's a total of 9, and there's a 9 in the written form, which means A is correct of 1,369. Next, we have what number is equivalent to 6,205. We can convert that written form either into expanded or standard form. So we have the number in the thousands place, 6,000. We look at both answers. We have 6,000 in A. We also have 6 in the thousands place in B, which is also 6,000. So they're both correct so far. Then we go to 200. In A, in the expanded form, 200 is in the correct spot. However, in B, the 2 is in the tens place, which would make it 20. So B is now incorrect. And then in the question, it asked for 5. So A would still be correct of 6,000 plus 200 plus 5. Next, we have what number is equivalent to 4,709. So first, we start with the thousands place, which is a 4, which means 4,000. So in expanded form, A, 4,000 is correct. And in B, written form, written out 4,000 is also correct. Next, we have in the hundreds place a 7, which is 700. So in A, it says 900, which is incorrect. But in B, it is written out as 700, which is correct. And then there's a 9 in the ones place, which makes B correct so far also again. Next, we have what number is equivalent to the blocks. So we start with the 1,000. There's one 1,000 block in this picture. So we look at the two answers. In the standard form, there is a 1 in the thousands place, which means A is still correct. And in the written form, there is written out as 1,000, which is also correct. Then we have the hundreds blocks. We have 4 hundreds blocks. In A, it is correct. There is a 4 in the hundreds place to represent 400, and same as B, 400 written out. Next, we have the tens blocks. There are 8 tens blocks. In A, we have 8, which is 80, which is also correct. However, in B, it says 50, which is not correct. Then we have the last, the single digits, the ones place, which we have 5, and that would make A still correct again as 1,485. Next, we have what number is equivalent to 3,706. So if we break it down, we have the 3 in the thousands place, so then we need 3,000. In A, 3,000 is represented, so makes A correct so far. And same as B, 3,000 is written out, which also makes it correct. Next, we have the 7 in the hundreds place, which makes, so then we'd have to find 700. In A, 700 is written in expanded form, so A is correct so far again. And same as B, 700 is written out in words, which makes it correct so far again. However, the 6 is in the ones place, so B would be incorrect as 6 is represented by tens is 60. So A would be correct as 3,000 plus 700 plus 6. Then we have what number is equivalent to the blocks. So as we can see, there are two 1,000s blocks, so we have to look for 2,000 in either the expanded or written form. In A, 2,000 is the first expanded number, so A would be correct so far, and same with B, as 2,000 is represented in words at first. Then we can see we have 500s blocks. So next we need to look at for a 500. In A, 500 is in the correct expanded form, so A would be correct so far again. However, in B, 600 is represented, which would make B incorrect. Then we look at the tens blocks, and we have 6 tens blocks, so we would need 60, which is represented in the expanded form, and 3 ones blocks, which is also represented in the standard form, making A the correct answer. Lastly, we have what number is equivalent to 6,000 plus 400 plus 20 plus 9. So we can either compose that into to standard form, or we can put it into words and see which one's correct. So first, we have the first expanded version of the number to be 6,000. So then we look for A in the thousands place. 6 is in the thousands place, so A is correct so far. In B, 6,000 is written into words, which also makes B correct so far. However, in the hundreds place in the expanded form, it's 400. But in A, the hundreds place is a 2, so A is now incorrect because that represents 200. However, in B, the hundreds place is 400, which makes B correct so far, but let's make sure the 29 is also there, which is 20 plus 9 in the expanded form, so B is the correct answer. Now, let's reflect on the lesson as a whole. How do you feel about everything we have learned? Are you confused? Do you need more practice? Or are you a pro and ready to move on? If you're still confused, please feel free to come up and ask any questions you have. I'm always here to help. If you need more practice, lucky for you, we are going to do some activities after this on rotating around the classroom, doing lots of practice on everything we've just learned. And if you're a pro and ready to move on, that's awesome. I'm happy for you. And we're going to do some more practice as well.